In this video, we'll talk about running multiple Guix packaged Shiny apps on a shared Shiny server. There are two ways to run a Shiny app. One is as a utility. In this method, you would have a bash file that would invoke the RScript executable, load your single file Shiny app, and run the app. This is useful when you want to invoke the app, use it, and then shut it down. Maybe you're hacking or it is an app that you use infrequently. The downside of this method is that you are instantiating a server every time you launch the bash script. One app, one server. A second way to run a Shiny app is on a shared server. You would do this when you want your apps to be available 24/7. Maybe these are an integral part of a LIMS system. These are apps that you can develop independently from other components of the LIMS system. When a systems approach is taken towards LIMS development, you have multiple independent pieces of software that communicate either by file transfer or update tables in a database or possibly communicate over sockets. Our core product, LIMS Nucleus, manages multi-well plates, tracks samples through plates, allows hits to be identified, and will operate liquid handling robots. As time passes, we may want to upgrade some of the functionality of LIMS Nucleus, possibly new hit identification algorithms, maybe QC visualizations. We can implement those as Shiny apps. That allows us to develop them independently and not touch the code base of the core product. In this video, we'll supplement the functionality of LIMS Nucleus with two utilities written as Shiny apps that we will get up and running on a Shiny server. These two apps are involved with mutation visualization and sequence evaluation. You can look at the details on the pages that are devoted to these apps. Mutation visualization allows you to look at the mutations introduced by PCR mutagenesis, and the sequence evaluation app allows you to evaluate the quality of Sanger sequencing runs by looking at the counts of ambiguities at each index of a batch of sequences. These two apps are available to you from the Lab Solutions channel. MuteViz is the mutation visualization recipe, and SeqEval is the sequence evaluation recipe. You can gain access to these by modifying your channels.scm, doing a Guix pull, and then you can install. Let's take a look at the files that are needed to package the Shiny app. I'll only look at one of my examples, the sequence evaluation. The other one, mutation visualization, is the same layout. So for sequence evaluation, we have 5 files. The first is the app itself. This is a single file that contains both the user interface and the server. SeqEval sh is the bash file that will allow you to run this as a utility. Forward and backward are 2 data files. These will be in the store and they will be available for download through the utility. And then there's the recipe file that will perform the packaging. Note that the layout that I'm going to show you allows you to run this app either as a utility or on a shared server. The same package can be run either way. You can load this on your desktop and use the bash file to launch it as a utility, or you can run it on a shared server. We will do that on Amazon Web Services, running both the sequence evaluation and the mutation visualization on a shared server. Here is app.r. I've already talked about packaging a Shiny app in a previous video, so I will only talk about the unique or notable changes in this file. So notice that I am loading the library seqnr. This allows me to work with DNA and protein sequences. The tag A, if you're using hyperlinks, A is shadowed by an A method in another library, so you need to use prepend with Shiny to use this particular tag. Here are my data files, forward and reverse. Note that they are prepended with the characters A through H. This is what I am going to replace with the substitute asterisk command in the recipe file. A through H will be replaced with path into the store. I have to do this multiple times, so by using this convention, I can have a single statement in the recipe file. And then at the end, I return a Shiny object. This is the bash script. So upon packaging, this will be substituted with the path into the store for the bash command. Our script will be in my profile so I can use it directly, but I need to prepend the app with the path into the store. Here is one of the data files. The forward reads, this is a standard FASTA DNA sequencing file. Reverse looks the same. Here is the recipe file, seqeval.scm. It is written as a module. It's on the Lab Solutions channel. I'm pulling from a commit. Here is where in both the bash file and in the app I substitute A through H with the path into the store. The bash file I need to wrap. And then here are my inputs. In particular, seqnr is a dependency. Here we are on my local machine. I've done a Guix package install seqeval. So it is installed now in my store. Note the name, KVGNN. So we can run the bash script. So now Shiny is running on my local machine. Note the A is coming from package seqnr. This is the A method that is masking the Shiny method. So now I can look on my web browser at this URL. Here we are in a browser at localhost port 6951, and I can see the app. I can browse and import my forward and my reverse multi-FASTA. And the app is running. This is local. Next, I will go to Amazon Web Services. So I need to do some pre-configuration. I'll be working with a Debian instance, T2 medium with 4 gigs of memory. I'll do an apt-get update, and I'll install the minimal software I need to get the Guix package manager running. I also installed GDebi core. This is so that I can install the Shiny server deb file that I download from RStudio. So this is not Guix packaged, this is a deb file. Next, I install the Guix package manager. using the install script that you can find in the Guix manual. Then I do a Guix package install glibc UTF-8 locales. I set up the Lab Solutions channel so that I can pull my 2 Shiny apps. I do a Guix pull, and I also open port 3838, which is the port on which this Shiny server will broadcast. So now on Amazon Web Services, I can look and see that the only thing that is installed are the UTF-8 locales. I can check the status of the Shiny server and see that it is running. So I'm going to make one edit to the server configuration file. So what I've done is I have changed in the server configuration file the run as Shiny. Normally the deb file will set up a Shiny user. I'm going to run it as admin because that is the account that I am under on AWS. So we can look at that file now. And see that the change has taken effect. I'm listening on port 3838. And here is the directory where I will find error logs, and here is the site directory. So it is directories under Shiny server directory that will provide the various apps to my server. Let's take a look at this directory. So we can see that there is a default index HTML and a sample apps directory. Let's see what is in those. This is the Amazon Web Service console. Here's my transient IP address. Let's go to that address. So here we are at that address. If we're seeing this, it means the server is installed and running, but we have some configuration issues, which is why both of these apps are not working. Also, the sample app will not work. So we need to go back to the console and install, using Guix package install, our Shiny, and for this bottom application to work, we need our Markdown. So back at the console now, we will install the dependencies of Shiny server as well as our 2 apps. This installation in real time takes about 6 minutes, so I will speed up the video. Let's update the profile and let's stop and restart the server. And let's see what we have installed now. So we've got our dependencies for the server and our two apps. Note the seek eval app, kvgnn. This is the same package that we installed on our local machine. This is the package we've now installed on Amazon Web Services and will run. We go back now to our Shiny app and reload, and now we see that both of the apps are running. So it looks like the server is properly configured. Now we can install our two apps. We can also look at the sample apps and see that is running also. So here at the Shiny Server console, if we look at the contents of Serve Shiny Server, this is where the sample app is coming from. We need to create subdirectories for each of the apps that we would like to serve. So I do that, and now we can look and see that we have two directories ready to hold our Shiny apps. Typically, you would place your app.r in this directory, or your ui.r, server.r if you have two different files. Our app.r is in the store, and we can get the path in the store by doing a list installed. So for mutation visualization, our path is here, and likewise for seek eval. So to place our app from the store into the Shiny server directory, I will create a symlink. So here I'm creating this file app.r in the Shiny server directory under muteviz, and it is a symlink to the app.r in the store. I do the same for the sequence evaluation. Now we can look and see in the seek eval directory we have our symlink to the app. And now if we go to the web page and look in muteviz, we can find our application running. I can download an example file. So now this is coming out of the store and being deposited into my downloads directory on my local computer. So now I can open this file and see the results. Likewise, seek eval should be available, and the same thing, I can download a sample file, browse, find my data, and load it. So in summary, we have packaged two simple Shiny apps. Each can be launched individually using a bash script and run as a utility on your local machine, or they can be loaded into a Shiny server. In our case, we are running on Amazon Web Services. These were simple apps opening a data file and presenting a visualization. Consider mutation visualization. That could encapsulate more of your workflow. You might point that app to a directory of DNA sequences, process through each sequence, translating it in the proper frame, run clustal-O to generate the alignment file, and then open the alignment file in your Shiny app. So these were simple to make a point, but they could encapsulate a lot more of your workflow. If you are concerned with reproducible computing, you may not be satisfied with this approach. The Shiny server software was not Guix packaged and so did not receive a hash code and will not be tracked by the Guix generation mechanism. Packaging Shiny server is a potential topic for a future video. If you have questions as to the suitability of LIMS nucleus for your process, contact us at info@labsolutions.com.